Hello, everybody. My name is Steven Ettinger, and today I'm going to be talking to you about the moon. I will be explaining some facts about the moon, why the moon orbits us, what's important about the moon to us, what the moon does, what it is made out of, and everything along those kind of lines and facts about the moon. It is very important to start off with what is the moon made of and the layers that it is composed of. There are four layers that the moon is actually composed of. One, the crust. Two, the rigid lithospheric mantle. Three, the non-rigid mantle. And four, the core. The layer of the moon, which is the crust, is actually very important to us. That is the very first layer of the moon. It helps us date the moon back to about 4.3 billion years ago as to when it formed, 60 years after the formation of the Earth. The moon's surface is dry, dusty, and rocky. The rocky crust is about 37 miles thick on the one side of the moon that faces the Earth, and about 62 miles on the thick on the other side of the moon, which faces away from the Earth. The second layer of the moon is the rigid lithospheric mantle. This is a rocky layer, and it's not hot enough to flow. It is the upper part of the mantle, and below it is the non-rigid mantle. But before I get to that, the rigid mantle is the hard shell, which is about 620 miles thick. The non-rigid mantle, which is the lower half of the mantle, is only the deepest part of this layer. It's hot enough to flow, but it is more rigid enough to transfer seismic waves throughout the moon. The fourth layer of the moon is the core. The core is a non-fluid core, which is composed of iron-rich rock. The core contains only about 2 to 4% of the moon's total mass. The core is probably about 225 miles deep. Um, the moon's magnetic field is only 1/10 of the Earth's magnetic field, which means if you were to use a compass on the moon, it wouldn't work as if it would on the Earth. So navigating on the moon would be pretty difficult, but since the moon is dark and it's dark out around the moon, you can navigate using stars. Um, so this is all the layers of the moon, and here is a quick picture of what the interior of the moon would look like. You have the mantle, you have the crust, and you have the core. These are the three layers of the moon, but there's really four subdivided layers of the moon's interior. Now that we know about the moon's layers, it's important to talk about the moon's axis compared to the tilt of the Earth's axis. The tilt of the Earth's axis is only about 23.5 degrees, but the tilt of the moon's axis is only about 1.5 degrees. This means that the moon would practically have no seasons, but since there is a vacuum in space and the atmosphere around the moon isn't as strong, there could be no seasons on moon regardless, because of there being no atmosphere. Here's a picture of the moon's axis compared to the Earth's. As you can see, it's slightly tilted going around the Earth, with the Earth being 23.5 degrees on its tilt. Now that we know about the moon's axis, we can talk about the moon's orbit around the Earth. It takes about 27 days, 7 hours, and 43 minutes for our moon to complete a full orbit around the Earth. This is called the sidereal month, and it is measured by the moon's position relative to a fixed star. However, though, it takes the moon about 29.5 days to complete its full phases of the moon. So our moon phases actually go over the period it takes for the moon to orbit around the Earth. Um, I will talk about the moon's phases shortly after this, but it is important for the moon and its orbit around the Earth with tides and relativity to the tides and the tide schedule that we are on Earth. Like I said, the moon's orbit around the Earth plays a very important part in our tide schedule and the tides that happen on Earth's surfaces. With the Earth and Moon system, gravity is like a rope that keeps pulling the two bodies together and is a configural force in what keeps them apart. Um, this force is greater than the moon's gravitational pull, which means that the oceans are going to move because of the force of gravity from that factor. Since the moon's gravity is not as strong, it pulls the water from the opposite side of the Earth and makes it larger, and like it bulges out, which is more like a high tide. And a low tide happens on the opposite side of where the moon isn't, and makes the water recede. Um, This can be predicted for sailors and sailing for times on when to come into shore, when to come out to shore, because the tide is such a variable and drastic difference. Here's a picture actually of what the tide really looks like. As you can see, on high tide, when the tide is in, there is the boat sitting on top of the water, and when it's out, there's a drastic difference where there is no water and the water is sucked out because of the moon. This happens every day, and the amount of hours that it happens is about 12 hours every day. So it is very predictable in terms of when a high tide will and when it won't happen. When the moon is going around the Earth in its orbit, it takes 29 days to go through 8 phases of the moon, as opposed to the 27-day orbit that the moon takes around the Earth. The first phase of the moon is the new moon phase, which is a pitch black moon where you can't really see the moon at all. It's very, very dim. It's not really lit up at all, and at this time the moon is not visible. Here's a picture as to what the moon would look like in a new moon phase. As you can see, there's only a white line around the moon, the circle, to show that the moon is actually present, and it's just black and it's not able to be seen. The second phase of the moon is the waxing crevice. It is a small part of the moon that is lit up. Less than actually half of the moon is lit up, but it is slowly getting bigger as it goes through its orbit. Here's a picture as to what the waxing crevice would look like. As you can see, it is only less than half of the moon that is lit up. Third phase of the moon is the first quarter moon, which is where half the moon is split, where the one half is bright and the other half is dark, and the brighter side is actually getting brighter as it moves forward in its orbit. Here's a picture of the third phase of the moon, the first quarter moon. As you can see, only half the moon is lit up. The fourth phase of the moon is the waxing gibbous, where at this time the moon is 3/4 of the way lit up. Waxing means slowly get bigger. So think of it this way: when anything says waxing, it's moving forward in its orbit. So it is getting brighter, and here is a picture of the fourth phase of the moon, the waxing gibbous, where, as you can see, only a little portion right here is dark, and the other 3/4 of the moon is lit up. This is slowly moving into the fifth phase of the moon, which is the full moon. The full moon is where you can see the whole moon. It's really bright. It lights up the entire night. It's really fascinating to see because you can see everything. It's really bright, and you can see all the craters on the moon and everything. Here's a picture of the full moon. This is halfway through the phases of the moon. This is the fifth phase again. So you can see everything when you could see the full moon because the sunlight is directed right onto the moon, and we can see the whole moon lit up. After the full moon phase is the sixth phase, the waning gibbous phase. The waning gibbous phase is where 3/4 of the moon is lit up and only a small portion, a quarter of the moon, is darkened. Waning means to slowly get smaller. Here's a picture of the waning gibbous. As you can see, 3/4 of the moon is lit up. This transitions into the seventh phase, the last quarter moon. The last quarter moon is where half the moon is lit up and half the moon is dark. This is the opposite of the first quarter. So here's a picture of the last quarter moon. As you can see, only half the moon is lit up, and this leads into the eighth phase of the moon. The eighth phase of the moon is the waning crevice, which is the opposite of the waxing crevice. So this is the last phase before the moon fully reaches the end of its cycle, the 29-day cycle, and it just goes over the 27-day cycle of the orbit. Here's a picture of the waning crevice. As you can see, 3/4 of the moon is darkened, and the 1/4 of the moon is lit up. So we know that waxing means to get bigger, and waning means to get slower and smaller. So now that we know that the phases of the moon, and we know the orbit of the moon and the tilt, they all play a very important part of a calendar, the tide schedule, and the amount of days and hours it takes for the moon to reach its full cycle of orbit around the Earth. Along with the phases of the moon come lunar and solar eclipses. A solar eclipse is an eclipse that occurs when the moon passes between the sun and the Earth, and the moon is fully or partially blocked. Here's a picture of what a solar eclipse might look like. As you can see, it's really dark with the moon, and only behind it the sun lighting up the moon. So you cannot really see the moon. It's almost black, and the sun around it is just illuminating it. The other type of eclipse is a lunar eclipse. A lunar eclipse occurs when the moon passes directly behind the Earth and causes a shadow. This can only occur when the sun, Earth, and moon are aligned. Here's a picture of what a lunar eclipse might look like. It looks as if the moon is lit up and bright and orange. You can see it very easily on a clear night, and it's actually really pretty to look at. They do happen occasionally. Sometimes there's slight eclipses where only part of the moon will be covered or brightened up. So you can't catch a full eclipse most of the time, but when there is a chance to see it, they will announce where and when you can see it and the best opportunity to see an eclipse. Now talking about the Earth's the moon's surface is the craters. The craters are a very unique part of the moon. Impact craters are some of the most dramatic features that can be seen on the moon. They are formed from meteorites, asteroids, and comets struck its surface in its past. Crater marks can be from millions and billions of years ago, even up to current days. You can see the craters clear at night. You can see that there's dark spots, light spots. The dark spots of the craters are known as the Maria, and they are when the asteroid or meteor or comet hits the moon. They create lava in the crater holes, and it rises and creates a dark ash-like feature when the lava cools at the surface of the moon, and that's what causes the dark and along with craters being visible on the moon's surface, you can also see footprints from the Apollo mission. Now, when we first stepped foot on the moon and we had the first leap for mankind by Neil Armstrong, we noticed that the footsteps on the moon stay there in place. They stay there in place because there's a vacuum in space, which means there's no oxygen, no atmosphere, or if there is an atmosphere, very little of an atmosphere, which means there can be no storms or movement. The only movement on the moon is that from an impacting asteroid or meteor, which causes dust clouds. But even then, nothing is going to move in space. The only time something can change the footprints on the moon's surface is if we went there to the moon and moved the sand around. It's not even really sand. It's more just dust, rock, and debris. And here is a picture of the first footprint taken on the moon by Neil Armstrong from the Apollo mission. The first mission to the moon that was successful on landing was in 1969 when we landed the Apollo 11 mission on the moon on July 20th, 1969. This was during the time of the space race where countries were competing in order to go to the moon of who could get there first and claim it. The United States was the first man-made mission to land on the moon, and we were actually able to put our flag on the moon, which is visible. You can definitely see it. And it's almost like a historic landmark for the U.S. that we were the first to go to the moon and make advances in our technology to get to the moon and see what was actually on the moon. Finally, I have some cool facts, interesting facts about the moon. The moon is not a planet, but actually a satellite to the Earth. The moon actually only orbits the Earth, but, I mean, if it only orbits the Earth and the Earth orbits the sun, would that mean that it orbits the Earth and the sun? But anyways, the surface area of the moon is 14,658,000 square miles, or 9.4 billion acres. Only 59% of the moon is actually visible at night to us. Like 59% of the surface is only visible by us. The moon rotates at 10 miles per hour compared to the Earth's rotation of 1,000 miles per hour. Those are some interesting facts that I found pretty cool about the moon. I hope that you enjoyed this video presentation and that I was a useful help to you in facts about the moon. I really did enjoy giving this presentation and finding cool facts about the moon. Like I said, the moon is very useful and cool to our planet with the tides and the phases. It's something really pretty to look at. It's actually spectacular to our Earth. So I really hope that you guys had an interesting time listening to my video and learning about the moon. Thank you so much. I'll take comments and I'll read yours, and I appreciate any bad or good comments. Please let me know, all right? Thank you.